All right, number 8. So if you look at this one, it says a local veterinarian clinic typically sees 15% of its horses presenting with a West Nile virus. So pretty much when they give me that, they're giving me P. So we know P is equal to 0.15. Actually, let me blow this up a little bit. All right, so far they're giving me P is equal to 0.15. It says if 10 horses are emitted during July, so they're telling me how many horses are they getting. So they're giving me N is equal to 10. So they're telling me if 10 horses are emitted during July, what is the probability that 2 or fewer horses among the 10 horses emitted have been affected with West Nile virus? So in this one, we want 2 or fewer. So that means X is equal to, well, 2. But we want it to be fewer than 2, which correspond to 1, and also correspond to 0. So one thing you kind of have to be able to recognize that this is a binomial distribution. So the reason why it's a binomial distribution, because you have 2 options. One of the options is they have West Nile virus. The other option, they don't have the West Nile virus. If you look at it, they tell you how many horses are they randomly selecting, and they're telling you X represent how many of them have the West Nile virus. All right. Any questions so far on how I got P and X, or that is a binomial distribution? Okay, so I'm gonna show you how to do this with ClassCalc. I'll also show you how to do it with the TI-83 for the people who are using the TI-83. So let me go over ClassCalc. All right, so for ClassCalc, what you want to go ahead and do, you want to hit the stats button. You want to hit distribution. And if you look right here, you want to hit the binomial distribution. So for binomial distribution, you want to enter the N. N is equal to 10. P is equal to 0.15. All right, everybody good so far? N is equal to 10, P is equal to 0.15. So the next thing we have to figure out, if we want to do CDF or if we want to do PDF. PDF if X is equal to only one value. CDF if we want to find a range. So if you look at it, since we want to find a range from pretty much 0 to 2, you want to do CDF. So CDF will say the lowest is 0, the highest will be 2. And we get the probability of 0.82. So we'll say probability is 0.82. Right. And that's it on how to get the answer for that one. So if you look at it, the answer for this one should be A. And let's save the answer. Right. Any question on how to deal with ClassCalc? Okay, so I'm gonna come and deal with the TI-83 or 84. So for the TI-84, all you have to do is hit second and hit the VARS button. Press up. If you look at it, you have binomial PDF, you have binomial CDF. We're gonna use binomial CDF. So for the trial is just another word for N. So they want you to put N. For P is the probability of success, so 0.15. X is your highest value that you wanted to get, and then it'll get it all the way to 0. So if you look at it, we want to find the probability X is equal to 0, 1, and 2. So the highest number of the 3 is 2. So what you do, you put 2, and that way the calculator is going to get you the probability of 2 Gonna get to the probability of 1 and get to the probability of 0, and gonna add all of those up for you. So we'll press paste. We'll press enter. And if you look at it, you get exactly the same answer that we got for class calc, which is 0.82019, but the 9 pretty much will round up the 1 to a 2. And that's it for A. Well, sorry, 8. But the answer should be A. Any question in regard to number 8? All right. So let me check out the chat. Hopefully there's some new questions there. All right, good. All right, so right now we got question 4, 9, and 2. So what I'm gonna do, I'm gonna take them in order. So we'll do 4 first, then I'll do 9, then I do 2. All right, so let's do 4. All right, perfect. So number 4, this is once again a binomial distribution. So we'll kind of go over why this is a binomial distribution. So it says a small class has 10 students. 7 of the students are male and 3 are female. You write the name of each student on a small card. The cards are shuffled thoroughly and you choose one at random. Observe the name of the student and replace it in the set. The cards are thoroughly reshuffled and you again choose a card at random. Observe the name and replace it in the set. This is done a total of 5 times. Let X be the number of cards observed in these 5 trials with a name corresponding to a male student. The random variable X has which of the following probability distribution? So if you look at this problem, nowhere in the problem do they tell me the mean or the standard deviation or the variance. So I automatically know it's not A, because if it's a normal distribution, it should tell me what the mean is, but it should also tell me what the standard deviation is. So I know it's not A, and I know it's not B. So up next is just B and C. So let me go to OneNote. So let's do a new one. So for this one, they tell me the amount of time that they're gonna do this. So they tell me how many times are they gonna reshuffle the card. If you actually read the problem, they told me they're gonna do this 5 times. So n is equal to 5. Up next, if you look at x, x is how many males? So if you look at X, it's telling me how many male did they select. So when they do the reshuffling 5 times, how many of those names were male names? So that means when I'm trying to find probability of P corresponds to what's the likelihood that I get a male. So if you look at the beginning, they say they have 10 students, and it says 7 of the students are male, 3 are female. So to get P, we have to do 7 divided by 10, because there's 7 male out of 10, so you get 0.70. And if you look at it, since you have a set of trials of how many times you're going to do this, and because you have a probability of success and failure, because right now a success is if the name is a male name, a failure is if it's a female name, you have a binomial distribution, because pretty much it's either going to be a male or a female, and you're doing this 5 times. And each event is independent from each other because they reshuffle the cards. So for this one, we want something that says binomial distribution, trial of 5, and P is equal to 0.70. So should be C. And that's your final answer. All right, so that's it for number 4. Any question in regard to 4? Okay, so let's do 9 now, and then we'll do 2. So for this one, it says at a large Midwestern college, 4% of the students are Hispanic. A random sample of 20 students from a college is selected. Let X denote the number of Hispanic among them. The probability that X is at least 1 is so on. All right, so let's go on to OneNote. So for this one, you kind of want to read the problem and see that they tell you how many students are they randomly selecting. So they tell you N is equal to 20 students. So they tell you that X is represented by how many Hispanic are among them. So P will equal to 0.04. Everybody good so far on my N value and my P value? So if you look at it, they want to find the probability that X is at least 1. So we want X, well, actually, let me type this one out. So we want X to be at least 1. So that means we want it to be 1. We want it to be 2, 3, 4, 5, 6, 7, 8, 9, 10. All the way down to 20. So that's my X value. So my X value, I want it to be all the way from 1 to 20. So I know N is equal to 20 students. I know P is equal to 0.04. And this is my X value. So this is a binomial distribution again. So since this is a binomial distribution, I'm going to do this in class calc. So in class calc, if you look at it, since I'm doing a range, I'm doing this from 1 to 20. So since I'm doing this from 1 to 20, you want to use the CDF option. So let me find class calc. There we go. So once again, you go to stats, you go to distribution, you go to binomial distribution, N is equal to 20, P is equal to 0.04. And then what we're gonna go ahead and do, we're gonna go ahead and just hit CDF. So for CDF, we put 1 to 20. So if you do 1 to 20, you get 0.5579, or you could say 0.558. So let me see which option do I have to put. Yeah, so if you look at it, they put 0.56. So that was it for 9. Any question on how I did 9 on class calc? Okay, so I'm gonna show you how to do this for the TI-83 because unfortunately for the TI-83, it doesn't have that option where you could put the range from 1 to 20. For the TI-83, we have to do it slightly a little bit different. So anytime we're finding the probability of at least 1, for the TI-83, what you want to do, you want to do 1 minus the probability X is equal to 0. So we're pretty much just using the complementary rule. Because if I find the probability that X is equal to 0, I can just do 1 minus that probability, and that would give me the probability of 1 all the way through 20. So that's how I'm going to do with the TI-83. Any questions so far for this formula? All right, so I'm gonna get the TI-83. So the TI-83, I'll do 1 minus, and then I'm gonna get second bars, and we're gonna do binomial. For this one, we're gonna do binomial PDF because we wanna find when X is exactly equal to 0. So we'll say trial is 20. We'll say P is 0.04. We'll say X is equal to 0. You go to paste. and you go to enter, and that's your answer. Because if you look at it, I'm doing 1 minus binomial PDF, which is 0.5579, which again, it will just round up to be 0.56. But that's it for 9. Any question in regard to 9?
I think it's more complicated using the TI than the actual problem.
Yeah, because like at least with the class calc, you could easily put the range. But if you have the TI-84, this is the way you want to do it in the TI-84. Right. So up next, I'm going to do problem number 2. So if you look at problem number 2, you actually just have to use the t-table again. So it says,
What about the gate?
So for question number 2, it says to calculate a 99% confidence interval, the value z in a margin of error should equal to. So we just want to find a z value for 99% confidence interval. So for this one, if you look at the bottom, you have 99% right here. And if you look right above it, you get 2.576. And we're done. So for number 2, you get 2.576. And that's how you find it. So you go 99% confidence interval, and you look for this z value. So you go 99% is right over here, and then you just get the z value of 2.576. Any question in regard to 2? All right, so question 13. So for question 13, it says the average age of the resident in a large residential retirement community is 69 years with a standard deviation of 5.8. So it says a simple random sample of 100 residents is to be selected, and the sample mean age of X bar of these residents is to be computed. The probability that the average age X bar of the 100 residents selected is less than 68.5 year is, so we have to do the math. So first I'm gonna go ahead and do is write out some information that's given to me. So I wanna write out what the mean is. I also want to write what the standard deviation is. Also, if you look, they give me a sample size. So let's do the easy one. What was the sample size that was given to me?
Is it 100?
Yeah, 100. So you put 100 here. What about for my mu? What was my mu given to be?
Is it 5.8?
Are you sure about that one? So that's actually your standard deviation.
Oh, 69.
Yeah, 69. And then what we want to do, we want to find the probability that X bar is less than 68.5. All right. Everybody good so far with those values? So if you look at it, I'm giving mu and I'm giving sigma. So that should be telling you that you want to do a normal distribution. So anytime I'm giving you mu and sigma, you want to do the normal distribution. So before we actually go ahead and start doing the normal distribution, first thing what we want to do, we want to adjust our standard deviation. So what I mean by adjust our standard deviation is we have to find what sigma of X bar is equal to. So from our sigma of X bar is equal to sigma divided by square root of n. So sigma is 5.8 divided by square root of 100 So that's 0.58. Everybody good where the 0.58 come from? All right, so let's go ahead and draw this out. So if you look in the middle will be 69. And then right to the left of it, you should have 68.5. So we want to find the probability that's less than 68.5. So we shade to the left-hand side. So let's go ahead and do this one. So for this one, you're going to go to normal distribution on class cow. You're going to tell it what mu is equal to. You're going to tell it what sigma is equal to, but you're also going to give it the lower bound, and you're also going to give it the upper bound. So for mu is equal to 69. Sigma is equal to the 0.58, because you want to give it the one that is adjusted. Lower bound, if you look at the lower bound, is here. So you keep on going to the left-hand side, so that's negative infinity. For the TI-84, you're going to put negative 10 to the 10 power. And lastly, for the upper bound is right over here. So that's 68.5. And that's exactly what we're going to put for the normal distribution for class cow. And also once we do it for the TI-82, we're going to put that information. All right. But any question in regards so far how I got this information? All right, so I'm actually going to do this first for TI-83 because I already have it here. So for the TI-83, what you want to do, you want to hit the second button, and you want to go right here where it says VARs. And then if you look right here, number 2, you use normal CDF. So for the lower bound, we're going to put negative 10 to the 10 power. For my upper bound, we're going to put 68.5. For my mu, we're going to put 69. And for sigma, we're going to put 0.58. And you go paste, you go to enter, and we get an answer of 0.1943, if I remember correctly. Right. So if we actually go to the test, if you look at it, that's going to be part D. So the answer for this one should have been D. Any question in regards to how I got D so far for this one? Okay. So now I'm going to show you how to do it with class calc. So for class calc, you want to go to stats. You want to go over to distribution. And if you look right here, you want to do normal distribution. So what you want to go ahead and do, put the mean. So this is the mean of the population. So you put 69. You put standard deviation of the sample size of 100, which is 0.58. You close it. Now you put CDF. So for CDF, if you look at the lower bound, it's already negative infinity. If you look at the upper bound, you have to put 68.5. And there you go. You get exactly the same answer of 0.1943, but pretty much just rounded up to 0.1945. And that's how you do number 13. Any question on how to do question 13? All right, so let me check out the chat, see if we have any new question. All right, so question number 15. All right, so if you look at question number 15, it says you measure the lifetime of a random sample 64 tire of a certain brand. The sample mean is X bar is equal to 50 months. Suppose that the lifetime for a tire of this brand follow a normal distribution with unknown mean and a standard deviation of sigma is equal to 5 months. a 99% confidence interval for mu is. So if you look at it, they want to do a confidence interval. So for the confidence interval, we first just want to notate everything that's given to us. All right, so let's see. Here, let me pull this more up. There you go. All right. So if you look at it, first they tell me the sample size, because they tell me they have a total of 64 tires. So if they have a total of 64 tires, that means N is equal to 64. They also told me we have a sample mean of 50, so you go X bar is equal to 50. They also told me standard deviation of the population, sigma, is equal to 5. Lastly, if you look at it, we want to do a 99% confidence interval. So this is all they gave us. So what we're gonna do, we're gonna do the confidence interval. So for this one, we're gonna be using the Z interval. All right, so for this one, I'm gonna show you how to do it with the TI-83. I'll also show you how to do it with the class calc. So let's do it with the TI-83. Shouldn't be that bad. So for the TI-83, what you want to do for this one, you want to go right here where it says stats. You want to move it over where it says tests. And you want to go all the way down to number 7 where it says Z interval. So if you remember, if you have data mean you don't know what the mean is, but we don't have data, we only have the statistic. So you want to say select statistic. So if you look at it, you want to put sigma. Sigma is equal to 5. My sample mean, well, my sample mean is 50. If you look at the sample size is 64. Confidence level is 0.99. We go to calculate. All right, so you get 48.39 to 51.6. Cool. All right, so that's C. And that's it for how to deal with the TI-84. If you're using ClassCalc, this is how you're going to deal with ClassCalc. So for ClassCalc, you go to the stats button, but now you're going to go over here where it says tests. So the test we're going to be using is the Z interval test. So you're going to put what sigma is equal to. So sigma in this case is equal to 5. The sample mean is equal to 50. And N is equal to 64. And lastly, confidence level is equal to 0.99. So if you look at what ClassCalc gave me, it gave me exactly the same answer that the TI-83 gave me, and that's answer C. And that's how you do 15. Any question in regard to number 15?
Yeah, wait. Just give me a second. I'm trying to put in the numbers myself.
Go for it.
Oh, okay, got it.
Perfect. All right. And that's problem 15. Any other question in regard to problem number 15? All right, let's go to the chat. Chat. All right, let's do 19. Okay, so let me go to my OneNotes. All right. So for problem number 19, here, let me lower the OneNote so you can see. It said a flip a coin, I flip a coin twice and count the number of heads. Which of the following is a valid assignment of a probability for the number of heads observed in 2 flips? So we just want to make sure, so it says a valid assignment of probability. So when it says that, it is referring to the 2 conditions. So the 2 conditions that we're talking about, that the probability has to be between 0 and 1. And when I add up all the probability, they have to add up to 1 or 100%. Everybody good with that? All right. So for this condition over here, if you're dealing with fraction, you pretty much just want the top fraction to be smaller than the bottom fraction. So we want to find value that looks something like this. If you get something that looks like this, then it doesn't pass that test. So all we're doing, we're just looking to see if the top number is smaller than the bottom number. Because the top number is smaller than the bottom number, then I know the probability between 0 and 1. Because like if you get this one, like if you do 15 divided by 13, you'll see how you get something bigger than 1. But if you do 13 divided by 15, now you see how between 0 and 1. So that's why you're looking for the top number to be smaller than the bottom number. So look at all of these fractions right here. Are all of these fractions good? Let's see something. So is 1 over 10 good? Yeah, so all of these fractions are good because all of them, if you look at 1 divided by 10, 5 divided by 10, 4 divided by 10, 1 divided by 4, 2 divided by 4, 1 divided by 4, 1 divided by 3, 1 divided by 3, 1 divided by 3. So all of them are good. So what I want you to do right now, I want you to add these 3 fractions. I want you to add D3 fraction. I want you to add D3 fraction, and let me know if it add up to 1. And I'll be right back.
You went to the restroom.
All right, so let's go ahead and do this. So let's add them up. So say if I do 1 divided by 10 plus 5 divided by 10 plus 4 divided by 10, you get 1. All right, so the first one is good. So A is a probability model. So let's do the second one. So if I do 1 divided by 4 plus 2 divided by 4 plus 1 divided by 4. All right, once again, you get 1. So that means B is also good. So now let's do 1 divided by 3 plus 1 divided by 3 plus 1 divided by 3. You get 1 again. All right. So if you look at all of these model pass the probability model because all of the probability are between 0 and 1. Also, if you add up each individual probability with each other, they add up to 1. So we'll put we'll put D. All of the answer option are correct. And we're done with 19. All right. Do we have any other questions? Let's check out the chat. Any other question, guys or girl? All right, 23. All right, 14. So we got 23 and then we'll go to 14. Perfect. All right, then 18. Sweet. All right, so for 23, say you arrive into a building and are about to take an elevator to your floor. Once you call the elevator, it will take between 0 and 60 seconds to arrive to you. We will assume that the elevator arrived uniformly. So this is important that they tell you is uniformly between 0 to 60 seconds. After you press the button, what is the probability that the elevator arrived between 20 to 33 seconds? So since they tell you uniformly, that means all of these seconds are equally likely. So equally likely that it'll arrive between 0 to 1 second compared to 59 to 60 seconds. So it's telling you all of the span of 1 second are equally likely to occur. So if you remember what we did for those type of problems, we actually drew a square. No, guess I have to erase you. So this means it has this type of distribution. So if you remember, it tells us that the pretty much the shorter amount of time that it's gonna take to arrive is 0 seconds. The longest it's gonna take to arrive is 60 seconds. So it's kind of telling us if I just happen to show up, press a button, I could either wait 0 seconds, or if I press a button, I have to wait 60 seconds. But it's telling us 60 seconds is the max amount that I'm gonna have to wait. All right. Any question in regard to that so far? All right. So up next, what we want to go ahead and do, we're gonna go ahead and find the height. So the height of this is 1 divided by b minus a. So that's 1 divided by 60 minus 0, which is just equal to 1 over 60. Any question? I got 1 divided by 60. Okay, so the last thing what we want to do, if you look at the problem, you want to know the probability that we wait anywhere from 20 to 33 seconds. So 20 to 33 seconds. So we'll say 20 somewhere over here. We'll say 33 somewhere over here. So here go 20. Here go 33. And we want to find this area. So I already know the height of this is 1 divided by 60. But I have to find what is the base of it. So to find the base, what you have to do, you have to take the difference of these two. So you do 33 minus 20, and you get 13. So that's the base of our rectangle. So since we know the base is 13, we know the height is 1 divided by 60. If I want to find this answer, we get the area. So we just multiply them out. So we'll say 13 multiplied by 1 divided by 60, and you get 0.2167. So 0.2167. Oh, it's 0.2167. So you get 21.7%. And we're done for 23. Any question for 23?
Could you do the calculation one more time?
Yeah.
I have a question.
So you're talking about just multiplying them up? So you do 13. You can multiply it by 1 divided by 60. And you get that. Or you could do 13 divided by 60.
Yeah, that's what I was gonna mention right now. Like, if you just did the 13 divided by 60, you'll get the same answer.
Yeah, because pretty much you do 13 times 1, which is 13. So then you go 13 divided by 16. And then.
Well, even then, it kind of tells you that because you said like it's equal amount, all of them.
Correct.
So, and since the time they gave you was from that to that, which was 13, it would just be like 13 divided by 60 is what I kind of thought.
Yeah, good. Yeah, perfect. Yeah, but that's how you do 23. So yeah, so you can either do like Adam said, like, hey, like 0 to 60, each one of them are equally likely. So that's where the 60 come from. And then since from, what was that, 20 to 33, there's 13 seconds. So you can do 13 divided by 60. But any other question in regard to 23? All right, so let's do 14. All right. So if you look at this one, they want to know the probability that the freshman is studying Spanish. So we want to figure out what this question mark is equal to. So if you remember when we did the one, I forgot which number it was. Where are you? Remember how we did 19 and we had to check the two conditions? So one of the conditions, all of the probability had to be from 0 to 1. The other probability, the other condition is that when you add them all up, it add up to 1. So going back to this, if I do Spanish plus French plus Swahili plus Chinese plus Arabic, it should add up to 1. So for this one, what we want to do, oops, that didn't work out. So what we want to do, we want to add, hey, French plus Swahili plus Chinese plus Arabic, that's equal to 0.52. So now I have to kind of think, okay, those 4 languages is 0.52, but there's only one more language left, which is Spanish. So once I add Spanish plus the 4 other languages, it should add up to 1. So we just have to just do 1 minus the 0.52.
0.48.
0.48. So that's C. So for this one, you have to just remember the condition that if you add all the probability, they should add up to 1. So all you have to do is add up these 4 individual probability, and then you do 1 minus those probability, and that will give you the probability of getting Spanish. So that's it for 14. Any question for 14? All right, and I think there was one more, number 18. So let's do 18. All right, so this one says, assume that you are about to buy a car. There's a probability of 0.4 that you will purchase a new vehicle and a probability of 0.5 that you will purchase a used vehicle. There's no probability that you will go home with more than one vehicle. The probability of the set of outcome is.
What?
Yeah. All right. So if you look at it, it says the probability of the set of all outcome is, so saying if I have all the different outcome, what should it add up to?
0.9.
Well, not 0.9, it should actually just add up to, is that a point? It should actually just add up to 1. Because this is going back to the, if you add up all the probability, it should always add up to 1. So if you look at it, it says the probability of the set of all outcomes. So that means the probability that they buy a new car, they buy a used car, or they don't buy a car. So if you add up all of the outcome, it should add up to 1. So that's kind of like a little trick question.
Because even though they don't mention that 0.1.
Yes, because they don't mention that 0.1, but since they say all outcome mean you include that outcome too. But if they ever said find the probability of all outcome, you should always just know it should always add up to 1, because if you saw this one, all of these, when we added them, they always added up to 1. So that's 18. Any question in regard to 18? All right, so let me go to the chat and see. Hopefully, maybe we have a question there. All right, any other questions?
Sorry. So the test is going to be available from when? The test 3? From what time to what time?
Friday to Tuesday. All right, let's see, there was a question. All right, question 21. All right. So for this one, said the probability that a randomly selected horse has this, given that it is fed more than 50% alfalfa, is all right. So right here, if you look at it, the given is that they were given more than 50% of alfalfa. So that means I'm going to use this right here. But if you look at it, they don't give me the total. So you have to find what is the total of this. So to figure out the total, where you going to say 0.08, add it up to 0.15. So the total is 0.23. So if you look at the problem, it says if they're in the case, that means they have the disease. If they're in the control, that means they don't have the disease. So if you look at it, we want to find the probability they have this disease given it is fed more than 50% alfalfa. So we just want to focus on this data set. So we only want to focus, well, I can't really do that, but I only want to focus on this and this. So what percentage of horses have that disease in this table or in this part that I'm circling? Well, if you look at it, only 0.08. So you do 0.08 divided by the total, which is 0.23, and you get that. So you get part A. And that's how you want to do that one. So the keyword here is given that. Given that, telling me we're only going to focus on this column. And then all you have to do is just look for how many horses have this disease. If you look at it, it says 0.08. So you do 0.08 divided by the 0.23, which we got from getting the total, because it didn't give us the total. All right, but that's it for that problem. Any question in regard to that problem? So let me see.
So you divided 0.08 divided by 0.23 and you got 0.034?
Correct.
Okay.
Yeah, you'd be on the lookout for a given that. Anytime you see given that, you should know it's a conditional probability. And whatever given after that, that's the condition. So in this case, the condition is that more than 50% alfalfa. So that way we select this one. So let me see, let me check the chat. All right. Any other questions? All right, 3. So supposedly population standard deviation is sigma is equal to 5, a simple random sample of n is equal to 110, and the confidence level is chosen to be 98%. So it said the margin of error for estimating mean mu is given by, all right, so this one, so they give me sigma is equal to 5. They give me sample size is equal to 100. They also give me confidence level is equal to 98%. And if you look at it, they want me to find margin of error. So you have to just remember the formula for margin of error says Z multiplied by standard deviation divided by square root of n. So this is going to be the formula that I want to use. All right. So any questions so far for any of my notation?
That's an E, right?
Correct. That's an E. All right. So if you look at it, I already know what sigma is. I already know what n is. The only thing I don't know what it is, I don't know what z is. And I'm going to use the t table to find that because I know confidence level is 98%. So I'm going to go over to t. If you look right here, here goes 98%. If you look right above it, it says 2.36. Bless you. Oh, yeah. Okay, 2.326. Right. Any question? I got the 2.326. Okay, so you multiply this by standard deviation, which is 5, divided by square root of 100. So for this one, if you do 2.326 times 5 divided by square root of 100 is actually 10. So I'm going to go ahead and do that. So we're going to say 2.326 multiply by 5 divided by 10. And you get 1.163. So you get 1.163. 1.163. So if you look at it, you just choose 1.165 because that's the closest one to it. Okay, if you look at 1.22a, it's not close to that. If you look at 0.1165, that's not the correct answer because it should be 1.1. And D obviously is not the correct answer. All right, but that's it for 3. Any question on how I did 3? All right, so let me check the chat. Any other question you want me to go over?
I have a question. Only for chapter 16 was mostly focused on the T table.
Correct.
Oh, okay.
Only chapters 16, we actually use a T table. Any other question, guys?
So the test is gonna be similar to this, right? Like to the study guide?
It should be
Like
similar.
online?
Like the one thing I'm gonna warn you about, like say, okay, like you see how right here I put sigma is equal to 6.5?
Uh-huh.
I'm not gonna do that. I'm gonna put like standard deviation of the population is equal to 6.5. So I'm actually gonna write it out versus giving you this symbol. So like it should be exactly the same. The only thing is like right here where I put sigma is equal to 6.5, I'm not gonna do that. I'll just put like the standard deviation of the population is equal to 6.5, and you should be able to label it. Or say, blah, blah, blah. Where's the other one? Or say like question number 3. It's not going to be this blatantly easy. Where if a sigma is equal to 5, n is equal to 100, like you should know n is your sample size. You should know sigma is standard deviation of 5. But yeah, the test should be something similar to this.
Okay.
So let's do number 7. So it says opinion poll find that 20% of American adults claim that they don't get enough sleep. Suppose you take a random sample of 200 American adults and you count the number of X in the sample that claim they never have time to sleep. The standard deviation of X is, so for this one, oops, sorry about that. I want that. All right. So let's go ahead and do this one. So we're doing 7. So they tell me n is equal to 200. They tell me p is equal to 0.20 because that's how many people feel they don't get enough sleep. So if you kind of look at this, there's only 2 options. It's either people who feel they get enough sleep or people who feel they don't get enough sleep. So that means Q is equal to 0.80. So this makes this a binomial distribution. Because they tell you how many times they're going to do the experiment. They tell you they're going to do the experiment 200 times. They tell you P is equal to 0.20. So that means Q is equal to 0.80. So this is a binomial distribution. So what we have to do, we have to do sigma is equal to square root of n times P times Q. So what we're going to go ahead and do, we're going to go ahead and multiply that out. So let me get class calc. Where are you? All right, so in class calc, all you have to do, say square root. So if you look at it, here goes square root of n, which is 200, multiply by 0.20, multiply by 0.80. And if you look at it, you get 5.66. So you get 5.66. And that's your answer for 7, 5.66. Any question for 7? Any other question?
I'm just hungry.
All right. Any last minute question? All right, so what we're gonna do, we'll just stop it right here and that'll be it. So you have to turn in by Tuesday. So Tuesday, you have until midnight. Well, technically not midnight, but you have till 11:59 p.m.
For everything?
Yeah, for the test and also for your homework.
Sounds good.
All right, so I'm gonna show you where to go for the test. So right here, test number test number 3 is right here. So let me make it visible for you. All right, so edit this out. No, don't want to do that. Oh, wrong one. So we'll make it available for student. So if you look at the test, for the test, you're gonna have 120 minutes to do it. Auto submit is on. So we'll say to display it for tomorrow. All right, so we'll say it'll be available for tomorrow at midnight. And we'll make this due all the way on Tuesday. And we'll make it due at the end of the day. All right. So yeah, so you'll find test number 3 right here, and it'll become available to you on May the 1st at 12 a.m. I'll also set up a little place for that way you could submit your homework. So for the homework, just upload the homework, and that way I could give you credit for it. You take a picture of it. If you can, there's actually like scanning apps on your phone. So that way, instead of having to like upload like 20 pages of pictures, it will actually just upload one PDF file for you. All right, but any question in regard to the test? All right. So once you do take the test, start switching your attention over to the final. So that way on Tuesday you can ask questions about about pretty much the final. For that way, because there's gonna be some stuff you might have forgotten. So just have some questions ready for Tuesday. Any last minute question?